In the last session, we solved the questions of what? We solved the questions of wave optics, interference and diffraction. Okay. And today we will be solving the questions of electrostatics. Okay. PYQs of electrostatics. And of course, you are solving the exercise 1 and 2. Okay. And the remaining exercise, that is the PYQ exercise, we are dealing with. Fine. So just give me a second. We'll start within a minute. Fine. Let everyone join also. All right. So shall we start now? Can you reply me once again? Shall we start? Yes. Okay. So let us start with the PYQs of electrostatics. PYQs of electrostatics. Okay. See, now this is the first question which is in front of you now. This is the first question. Okay. You can see the cursor there. Let me read the question. Let us deal with this question. The first question is, figure shows 3 points A, B and C in a region of uniform electric field. So here we have uniform electric field going from left to right. Okay, going from left to right. The line AB is perpendicular and the line BC is parallel to the field lines. Okay, so these are the field lines. These are the left to right field lines. Line AB you can observe here. Okay, line AB you can observe here. Okay, this line AB is perpendicular to the field line and the line BC is parallel to the field line. Okay, fine. So what they are asking, which one of the following holds good? So these are the options. Okay, which option is the correct one? That we have to find out. Now very simple thing. Always remember that electric lines of force always point from higher potential to lower potential. Okay, electric field lines always point from higher potential to lower potential. So it is very much obvious that point B is higher potential than the potential at point B will be higher than the potential at point C. Potential at point B is higher than the potential at point C. So check what are the options where they are saying potential at point B is higher than the C. Option 1 is wrong because B equal to C. Option 2 can be correct. Option 2 can be correct. Option 3 wrong because B is higher potential. Here they have said B is lower potential than the C. No, B should be higher than the C. Here also B equal to C. So you people tell me what should be the answer. I told you the logic. Now you people shall tell me what should be the answer. A, B, C, D. पटकन बोला. Exam ला लेला question है. Do we know the fact that electric lines of force always start at higher potential and end on the lower potential, or they are directed from higher potential to lower potential? So what should be the correct answer? We know B is the higher potential point and C is the lower potential point. Then what should be the answer? Reply fast. Let the answer come from you. Answer तुमच्याकडे येऊ दे. What is that? No one answering. Option 1, 2, 3, 4. Yes, it is option number 2. It is option number 2. Why? B is higher potential, C is lower potential. Only one option is saying that B higher potential, C lower potential. Okay, all other options, nowhere they have included that B higher and C lower. Now let us discuss why potential at point A and potential at point B are equal. Why potential at point A and potential at point B equal? Because always remember that we know the concept of equipotential surfaces. We know the concept of equipotential surface. And we know equipotential surfaces are the surfaces which are perpendicular to the electric field lines. So these are the electric field lines going from left to right. These are the electric field lines which are going from left to right, and perpendicular to that this line AB is there. perpendicular to that this line AB is there. So all the points on the line AB are having same potential. So all the points on the line AB are at same potential. The potential of point A must be equal to potential of point B because they lie on equipotential surface. How to draw equipotential surface? By drawing a perpendicular surface to the electric field lines. Okay, and in the direction of electric field, what you can decide? You can say that electric lines are directed from higher potential to the lower potential. So thereby we can simply say that for question number 1, write along with me. Just write potential at point B A is equal to potential at point B. Reason: equipotential surface, this is the reason. Okay sir, fine. And why potential at point B is more than potential at point C? Because, write down, because electric lines are directed from electric field lines direction काय असते? Electric lines are directed from higher potential to lower potential. Okay, these are the facts behind the question number 1. Okay, shall we now move on to the question number 2? Everyone just reply me clear and written so that we can move on to the next question. Therefore VA equals VB more than VC. Just reply me CW, that won't take much time. After every question I will be waiting for your response. Okay, all these things we are doing for you only. So you shall be replying. Okay, fine. So let us deal with the next question, that is question number 2. Let us see what is given in the question number 2 and let us tackle the question number 2. Fine. So you can follow the cursor now. Observe here. Question number 2. Charges plus Q and minus Q are placed at points A and B. So here you can see the point A. Here you can see point B. At point A there is a plus Q charge. At point B there is a minus Q charge. Okay sir. Respectively, which are at a distance of 2L apart. Okay. Total distance between A and B is 2L. Okay. Point C is the midpoint between A and B. So this point C is midpoint between this A and B. All right. So AC distance must be L, CB distance must be L, and total distance from A to B is 2 times L. Okay sir, fine. Point C is the midpoint between A and B. The work done in moving a charge plus Q, okay, plus capital Q along the semicircle CRD. Along the semicircle CRD is equal to, so what we are asked? We are asked the work done. So work done is equal to question mark. Work done is equal to question mark. Very simple question this is. So let us draw the geometry first. So here we have some point A, here we have some point C, and here we have some point B. Okay, fine. Now you just keep on observing and keep on writing along with me. Here we have some point D. We have one arc like this. This is point what? This is point R. Yes sir. Now we have to move a plus Q charge, plus capital Q charge from point C ultimately to point D. So in this way, on this path we have to move the plus Q charge. Fine. Here at point A, it is given in the question that plus Q charge is placed at point A and minus Q charge is placed at point B respectively. So at point A we have plus small q charge, at point B we have minus small q charge. Okay sir, fine. Now what are the distances? This total distance is already given to us in the question as 2 times L. Then they said the point C is the midpoint. So this distance must be equal to L. Now being the semicircle, if this distance is L, if this radius is equal to L, then this distance, that is this radius, is also going to be equal to L. Fine sir. Now what is the W? W is equal to VQ. W is equal to VQ, potential difference into charge. Okay. So what is being asked? We have to write the formula for what is being asked. Sir, we are asked W. W is equal to VQ or V into delta Q. delta V into Q, potential difference into charge. Actually, generally we say W is equal to VQ, where V is the potential difference. Okay. Now let us write the potential difference as delta V. Now we know to find out potential difference, the path doesn't matter. To find out potential difference, the path doesn't matter. What we have to find out is this. See, to find out the potential difference, what we can do? To find out the potential difference, we can simply say potential at final point minus potential at initial point. So final point is point D, initial point is point C. So just write final point minus initial point. Potential at final point D minus potential at initial point C, potential difference into charge. Which charge is to be moved? Sir, plus capital Q charge is to be moved. So Q is nothing but Q itself. Q la Q चा आता. Okay. So this is the work done, which is equal to VQ. W is equal to VQ, where V is the potential difference. To find out the potential difference, just do the final potential minus initial potential. Now call this as equation number 1. Call this as equation number 1. Now if you observe the options, options are in the language of small q, capital Q, L and 4 pi epsilon 0. Small q, capital U, capital Q, L and epsilon 0. Small q, capital Q, L and epsilon 0. All the options are in the language of small q, capital Q, L and epsilon 0. Okay, sir, fine. Now, to bring the options in terms of small q, capital Q, epsilon 0 and L, what we have to do? This capital Q is already in the is already there. So we need to replace potential at point D and potential at point C. Fine, very simple thing. How to find out potential at point C? See, very simple thing. Potential is a scalar quantity. So to find out total potential at point C, because of this plus Q charge and this minus Q charge, see, we have to move plus positive Q, plus capital Q from C point to D point. So at this point, find out the potential due to plus small q and minus small q. हा जो काय plus q आणि minus q दिसतोय, याच्यामुळे किती potential आहे बघा इथं. That will be the potential at point C. Now potential because of this charge and this charge. How to find out potential due to system of charges? Find out potential due to first charge, find out potential due to second charge and just add them. ठीक है? So let us do that. What is the potential formula? Sir, potential formula due to a point charge at distance r is kq upon r. So potential at point C because of first charge will be equal to k. K is 1 upon 4 pi epsilon 0. Q is what? Small q divided by r. What is this distance AC? Sir, this distance AC is nothing but L. See, this total distance is 2L. C is the midpoint. Total distance is 2L. C is the midpoint. So this half distance will be equal to L. So KQ upon R will become KQ upon L. This is the potential at point C because of first charge. Plus because of second charge, what will be the potential? Again KQ upon R plus K. What is Q? Sir, Q is equal to minus Q. Q is equal to minus Q. What is R? What is this distance? Sir, this distance is L. So write down this. Sir, KQ upon L minus KQ upon L will become 0. Yes, that will become 0. Fine. So we have now the value of potential at point C. Similarly, find out potential at point D. Similarly, find out potential at point D and keep on writing along with me. Now, potential at point D. Potential due to first charge plus potential due to second charge. A मुळे किती potential, B मुळे किती potential. So again, formula for potential is KQ upon R. Fine. Formula for potential is KQ upon R. So K, what is Q? Q is Q upon R. What is this total distance R? Sir, this 2L plus L, that will become 3L. Okay. This 2L plus L, that will become 3L. Fine. So K, Q upon R. R is equal to 3L plus because of this point B. तिथं एवढा charge आहे त्याच्यामुळे इथं potential किती येणार? Again KQ upon R. K is K. What is Q? Sir, Q is minus Q. Q is minus Q. So K into minus Q upon R. What is R? What is R? R is equal to L. What is R? R is equal to L. So write down there L. Fine, sir. Now what you can do? You can take this KQ upon L common. You can take this KQ upon L common. Just give me a second. You can take this KQ upon L. KQ upon L common. K. Q upon L, we can take that common. So what here remains? 1 upon 3 minus KQ upon L is common. 1. This minus here, so 1 here. So 1 by 3 minus 1, what will be that? Minus 2 by 3. That will be equal to minus 2 by 3 times kq upon L. Fine, sir. Now we have the value of potential at point D. D च potential कळालं. We have the potential at point C. Now just put the values of potential here, here, and just multiply it by Q. That's it. We will get the final answer. So therefore, equation 1 becomes, therefore, equation 1 will become total work done is equal to, what is that? Vd minus Vc into Q. What is Vd? Sir, minus 2 by 3 kq upon L. Minus 2 by 3 kq upon L. Okay, potential at point D. Minus Vc. Minus, what is Vc? Sir, potential at point C is 0. So 0, put the bracket. Multiplied by what? Multiplied by capital Q. So multiplied by capital Q. Fine. So this minus 2 upon 3 as it is. Minus 0, no need to write. Now k we have to replace. We have to write the answer in terms of epsilon 0. So k can be replaced by 1 upon 4 pi epsilon 0. So k is replaced. This small q as it is, this capital L as it is, and then this capital Q as it is. Okay. Now here you can very easily observe this minus is going to remain as it is. This 2 upon 4 will become 1 by 2. This 2 upon 4 will become 1 upon 2. That 2 into 3 will become 1 upon 6. So minus 1 upon 6 pi epsilon 0 minus 1 upon 6 pi epsilon 0 small q capital Q upon L. So what shall be that option? I think that shall be the option number D, Delhi. Okay, write it down and let me know in the chat box if it is clear or not. Shall I make my video on? Everyone now reply me in the chat box, clear and written. Good. व्हिडिओ ऑन केला तर चालेल का? क्लिअर दिसते का तुम्हाला स्क्रीन? का जास्त नीट जाते तुमचं? You can position that video anywhere on the screen you want. Okay, तुम्हाला जिथं पाहिजे तिथं तो व्हिडिओ मूव्ह करून तुम्ही ठेवू शकता. ओके, फाईन, चालेल ना? ओके, म्हणजे तुम्हाला क्लासरूम फिलिंग पण येईल. फाईन. सो क्वेश्चन नंबर 2 पण झाला. नेक्स्ट क्वेश्चन नंबर 3. लेट अस डील विथ द क्वेश्चन नंबर 3. बघा, सिंपल थॉट्स आहेत, अप्लाय करूयात. नेक्स्ट लेट अस डील विथ द क्वेश्चन नंबर 3. Let us read the question and let us try to extract the data. 3 point charges plus q minus 2q and plus q are placed at the points x equal to 0, y equal to a, z equal to 0. First point. Second point is x equal to 0, y equal to 0, z equal to 0. Okay. Third point is x equal to a, y equal to 0 and z equal to 0 respectively. The magnitude and the direction of the electric dipole moment. Okay, electric dipole moment we have to find out. The magnitude and direction, okay, of the electric dipole moment of this charge assembly are. Okay, fine. Let us try to draw that charge assembly. See, the first point is on the y-axis. The first point is on the y-axis. X equal to 0, z equal to 0 means y equal to a. Y equal to a means what? Y equal to a means it is a y-axis. So let us draw y-axis. Let us draw the y-axis. Let us draw the origin. Okay, and this is the point y equal to a. So here we have the first point charge plus q. इथं आपला पहिला point charge असेल plus q. Fine. Next, minus 2q is located at x equal to 0, y equal to 0 and z equal to 0. It means origin. Origin ला minus 2q आहे. At origin we have minus 2q. Fine. This is our origin. This is our y-axis. Next. And x equal to a, y equal to 0 and z equal to 0. X equal to a, y equal to 0, z equal to 0. X equal to a कसं काढशील बाळ? Let's draw the x-axis first. This is origin and this is x equal to a. Okay, this is x equal to a. याचा coordinate काय आहे? याचा coordinate आहे x equal to 0, y equal to a, z equal to 0. This is origin, so its coordinates are 0, 0, 0. This is the third point charge plus q is on the y-axis, so it shall be, so no, third is on the x-axis, so x equal to a, y equal to 0, z equal to 0. Fine, x equal to a, y equal to 0, and z equal to 0. Fine. Now we have to find out the direction and magnitude of dipole moment. Direction and magnitude of dipole moment. So write down magnitude and direction, magnitude and direction of net dipole moment of this charge assembly. Net dipole moment, magnitude and direction of the net dipole moment is equal to question mark. Okay, now this is very simple question. What you have to do, first you have to create two dipoles. Okay, here plus q and minus q. See, minus 2q are there. Minus 2q can be split into 2 times minus q. 2 times minus q. दोन वेळा मायनस क्यू घेता येतात. त्यातला पहिला मायनस क्यू इथे घ्यायचा आणि दुसरा मायनस क्यू इथे घ्यायचा. म्हणजे काय होईल, एक डायपोल मोमेंट असा मिळेल, प्लस क्यू मायनस क्यू असा एक डायपोल मोमेंट तुम्हाला मिळेल. वी नो डायपोल मोमेंट इज ऑलवेज डायरेक्टेड फ्रॉम निगेटिव्ह टू पॉझिटिव्ह. सो दिस इज अवर फर्स्ट डायपोल मोमेंट. नाव इथं मायनस 2q आहे, त्यातला एक मायनस क्यू आपण इथं वापरलाय. ओके, विथ दिस डायपोल. ओके, फॉर दिस डायपोल. नाव फॉर दिस डायपोल here we have again the plus q charge. You can observe here in the question what are the charges we are given, plus q, minus 2q and plus q. त्या मायनस 2q ला एक तर मायनस क्यू इथे घेतलाय, दुसरा जो काय मायनस क्यू आहे ना तो इथे घ्यायचा. ओके, यातला एक मायनस क्यू घेतला, एक प्लस क्यू घेतला, एक इथं प्लस क्यू घेतला. ओके, नाउ अगेन द डायपोल मोमेंट इज फ्रॉम निगेटिव्ह टू पॉझिटिव्ह. ओके, व्हॉट इज दिस डिस्टन्स, हे सेपरेशन किती आहे बाळ? सर दिस सेपरेशन इज a. सर दिस सेपरेशन इज ऑल्सो a. This separation is a. This separation is also a. आता डायपोल मोमेंट कसा असतो, लेट अस फाइंड आउट फर्स्ट डायपोल मोमेंट. पहिला डायपोल मोमेंट P1 किती येणार बाळ? फर्स्ट डायपोल मोमेंट इज वन ऑफ द चार्ज इनटू डिस्टन्स बिटवीन देम. या दोन्ही पैकी एक चार्ज इनटू डिस्टन्स बिटवीन देम. व्हाट इज दॅट डिस्टन्स? इट इज a. पहिला डायपोल मोमेंट झाला. सेकंड डायपोल मोमेंट P2, दॅट विल बी इक्वल टू व्हॉट? वन ऑफ द चार्जेस, दोन पैकी एक चार्ज इनटू डिस्टन्स बिटवीन देम, दोघांमधलं डिस्टन्स. सो क्यू इंटू ए, क्यू इंटू ए. आता मला सांगा, एक वेक्टर असा आहे, दुसरा वेक्टर असा आहे. पहिला वेक्टर असा आहे, दुसरा वेक्टर असा आहे, दोघांमध्ये अँगल 90 आहे. इफ देर आर टू वेक्टर्स, ओके, अँड इफ द अँगल बिटवीन देम इज 90, देन व्हॉट इज द रिझल्टंट? नेट डायपोल मोमेंट काय येणार? दोन वेक्टर मधला अँगल जर 90 असेल तर अंडर रूट पहिल्या वेक्टरचा स्क्वेअर प्लस दुसऱ्या वेक्टरचा स्क्वेअर. सो अंडर रूट क्यू इंटू ए ब्रॅकेट स्क्वेअर plus q into a bracket square. So q into a square plus q into a square 2 times q into a square. बर, स्क्वेअर आणि स्क्वेअर रूट कॅन्सल होते, स्क्वेअर आणि स्क्वेअर रूट कॅन्सल होते, रूट 2 ऍज इट इज राहते. सो व्हॉट इज द आन्सर? रूट 2 टाइम्स q इंटू a. आता लगेच ऑप्शन्स कडे जायचं. रूट 2 टाइम्स q इंटू a कुठल्या कुठल्या ऑप्शन मध्ये दिले बघा. रूट 2 q इंटू a पहिला ऑप्शन तर आहे. रूट 2 इंटू q इंटू a दुसऱ्या ऑप्शन मध्ये पण रूट 2 इंटू क्यू ए आहे. थर्ड ऑप्शन मध्ये क्यू ए लिहिलंय, सो थर्ड ऑप्शन रॉंग. थर्ड ऑप्शन रॉंग. फोर्थ ऑप्शन मध्ये रूट 2 इंटू क्यू इंटू ए आहे. सो ऑप्शन 1 कॅन बी राईट, 2 कॅन बी राईट अँड 3 कॅन बी राईट. तुम्हीच मला सांगा, फर्स्ट वेक्टर इज लाईक दिस, सेकंड वेक्टर इज लाईक दिस. सो टेल मी, इफ द फर्स्ट वेक्टर इज लाईक दिस P1 and second vector is like this P2, then certainly resultant is going to be like this. Not along x-axis, not along y-axis, but something like this. Something like this. So option 1 येणार होता रूट 2 इंटू क्यू इंटू ए, बरोबर येऊ शकला असता. ऑप्शन 2 पण येऊ शकला असता, ऑप्शन 4 पण येऊ शकला असता. पण अलॉंग प्लस वाय ऍक्सिस म्हटले, अरे एक वेक्टर इकडे आहे अलॉंग प्लस वाय, दुसरा वेक्टर अलॉंग प्लस एक्स आहे. रिझल्टंट असा येणार आहे, नेट डायपोल मोमेंट असा येणार आहे, नॉट अलॉंग एक्स, नॉट अलॉंग वाय. सो ऑप्शन 1 पण गेला. ओके, असं स्मार्ट थिंकिंग करायचं आहे. ऑप्शन 1 पण गेला कारण इथं प्लस वाय म्हटलंय. ऑप्शन 4 पण गेला कारण इथं प्लस एक्स म्हटलंय. मग ऑप्शन 2 इज द करेक्ट आन्सर. ऑप्शन 2 इज द करेक्ट आन्सर. समजलं का? एव्हरीवन शॅल रिप्लाय इन द चॅट बॉक्स. मग पुढे त्यांनी जे काही लिहिले ते बरोबर असणार. अलॉंग द लाईन जॉईनिंग दी पॉइंट्स एक्स इक्वल टू 0, वाय इक्वल टू 0, झेड इक्वल टू 0 म्हणजे ओरिजिन. ओरिजिनच ना. एक्स इक्वल टू 0, वाय इक्वल टू 0, झेड इक्वल टू 0 म्हणजे ओरिजिन. आणि कुठला पॉईंट जोडायचा आहे? x इक्वल टू ए, y इक्वल टू ए, z इक्वल टू 0. अरे z इक्वल टू 0 आहे ना, आणि x च्या आणि y च्या काहीतरी व्हॅल्यूज दिलेत आणि त्या व्हॅल्यूज इक्वल दिलेत, म्हणजे XY प्लेन मधला एक पॉइंट आहे, तर तो हा पॉइंट असणार जिथे x इक्वल टू ए आहे, y इक्वल टू ए आहे आणि z इक्वल टू 0 आहे. या दोन पॉइंट्सना जोडणाऱ्या लाईनच्या अलॉंग. बरोबर आहे. सो ऑप्शन नंबर 2 विल बी द करेक्ट आन्सर. रिप्लाय इन द चॅट बॉक्स क्लिअर अँड रिटन. CW लिहून घ्या आणि CW रिप्लाय करा. गुड. क्वेश्चन 3, 3 क्वेश्चन संपले. जस्ट रिप्लाय मी CW. क्रिटिकल क्वेश्चन्स आहेत पण समजतात का चेक करा. आणि एक्झामला आलेले पण क्वेश्चन्स आहेत, सो त्याची प्रॅक्टिस झालेली जास्त चांगली. नेक्स्ट क्वेश्चन नंबर 4. चला क्वेश्चन नंबर 4 कडे चला. लेट मी रीड द क्वेश्चन. Let us deal with the question number 4. You also write down question number 4. Let's see what is given in the question number 4. A hollow cylinder has a charge q coulomb within it. Okay. Inside a hollow cylinder, let's draw a hollow cylinder like this. And inside that hollow cylinder, we have one charge. Where that charge is placed, we don't know. So let us not place a charge right now immediately. A hollow cylinder has a charge q coulomb within it. If phi is the electric flux in the units of voltmeter, SI unit दिले. See, I already told you that electric flux unit काय असते बा? Electric flux unit एका इन्स्ट्रुमेंटचं नाव पण आहे. So that is voltmeter. आणि magnetic flux unit काय आहे? Weber. Electric flux unit काय आहे? Voltmeter. Magnetic flux unit काय आहे? Weber. A hollow cylinder has a charge plus q coulomb within it. Okay. If phi is the electric flux in the units of voltmeter associated with the curved surface of the B. With the curved surface, we have total flux phi. Okay, sir. So flux associated with the curved surface is equal to किती दिलंय? Phi. Fine, sir. The flux linked with the plane surface A in the units of voltmeter will be. Plane surface A diagram दिले का बघूया. Are we given the diagram? Yes, we are given the diagram. The cylinder is not like this. The cylinder is like this. Fine. This is the surface A, this is the surface B, and this is the curved surface. Fine. So at somewhere inside we have charge Q. Okay. So my mistake. Here the point C is there. And B is the curved surface. A is the circular surface. C is the circular surface. Fine. What we are asked? We are asked the flux associated with the surface A, or the flux cutting the surface A. Flux A surface ला cut करून किती flux जात आहेत? Simple thought आहे. मला सांगा, how many flux emerge out of a charge Q? Q एवढ्या चार्ज मधून किती फ्लक्स बाहेर येतात? Q एवढ्या चार्ज मधून किती फ्लक्स बाहेर येतात? Answer is Q upon epsilon. Always remember. So total flux कसं लिहायचं बघा. So total flux associated with this entire cylinder म्हणजे काय? या सिलेंडर मध्ये enclosed charge upon epsilon 0. Q enclosed upon epsilon 0. Total flux associated with this entire cylinder will be equal to what? Total charge enclosed upon epsilon 0. Q upon epsilon 0. So write down here Q divided by epsilon 0. हे total flux झाली. But sir, total flux is equal to flux associated with A plus flux associated with C plus flux associated with B, or you can simply write flux associated with A plus B plus C. Now out of which A and C are the circular surfaces. जेवढे या सर्क्युलर सरफेस मधून जात असतील तेवढेच यात पण जात असतील. सिमेट्रिकली आहे ना, बरोबर मिडलला प्लेस आहे ना तो. मग ए मधनं जेवढे गेले असतील तेवढे सी मधनं पण गेलेले असणार. सो ए आणि सी चे इक्वल आहेत. सो त्याला काय लिहूयात? 2 times A. याला आपण phi H म्हणूया, याला आपण phi H म्हणूया. इज इक्वल टू Q अपॉन इप्सिलॉन 0. बरोबर, इज इक्वल टू Q अपॉन इप्सिलॉन 0. फ्लक्स असोसिएटेड विथ द बी, त्यांनी काय दिलंय? phi दिलंय. त्यांनी काय दिलंय? phi दिलेलं आहे ऑलरेडी. ठीक आहे, बघूयात. सो याला काय लिहूयात? प्लस phi असं लिहूयात. इज इक्वल टू व्हॉट? फ्लक्स असोसिएटेड विथ ए आणि सी ते तर इक्वल आहेत. सो ए आणि सी जर इक्वल असतील तर त्याला ए प्लस ए 2 times ए म्हणा, कारण ए कॅल्क्युलेट करायचं आहे. फाय ला फ्लक्स असोसिएटेड विथ बी ला काय म्हणा, फाय म्हणा, इज इक्वल टू व्हॉट, क्यू अपॉन इप्सिलॉन 0. आता मला सांगा व्हॉट इज द फायनल आन्सर. वी आर आस्क फाय ए, सो लेट अस राइट 2 टाइम्स फाय ए is equal to this q upon epsilon 0 as it is and this phi on the right hand side minus phi. गडबड करायची नाही. 2 टाइम्स फाय ए विचारले का, नाही. पटकन हे आन्सर सिलेक्ट करायचं नाही. फाय ए विचारलाय, फ्लक्स असोसिएटेड विथ ए विचारलाय, बी चे दिलेले, ए चे विचारले. अरे पण जेवढे ए ला असतील तेवढे सी ला असतील ना, मग ए चे प्लस बी चे प्लस सी चे इज इक्वल टू टोटल फ्लक्स. आणि टोटल फ्लक्स काय शिकवलेत, टोटल फ्लक्स असोसिएटेड विथ द चार्ज क्यू इज क्यू अपॉन एप्सिलॉन. एवढ्या सगळ्या सिलेंडर मधून किती फ्लक्स बाहेर पडतील, जेवढा चार्ज इनक्लोज अपॉन एप्सिलॉन और एप्सिलॉन 0. सो फ्लक्स असोसिएटेड विथ ए विथ सरफेस ए इज इक्वल टू, हा 2 डिवाइड करायला जाईल, सो दॅट विल बिकम 1/2 इनटू ब्रॅकेट q upon epsilon 0 minus phi, q upon epsilon 0 minus phi. So correct option should be option number D. Okay, so reply me in the chat box, is this question clear to all of you? Just reply me clear and written, everyone. Tell me, just reply me clear and written, write it down and reply me in the chat box. Is this question clear to all of you? Waiting for your response. Yes, ठीक है, समझला. चला पुढं, question number 5. Let us deal with the next question. Fine. Let's see what is the question. Let us read it. A spherical rubber balloon carries a charge that is uniformly distributed over its surface. So we have a spherical rubber balloon. Okay. What is the charge? It is uniformly distributed over its surface. Okay, that charge we just don't know. Let's say the charge is Q and it is uniformly distributed over the surface of the balloon. All right. As the balloon is blown up, as the balloon is blown up, म्हणजे काय, अजून जरा हवा त्याच्यामध्ये आत गाठली आणि हा बलून काय केला, थोडासा एक्सपांड केला. ओके, फुगवला. ब्लोन अप मीन्स थोडासा एक्सपांड केला, फुगवला. हाऊ डज इलेक्ट्रिक फील्ड ई व्हेरी इनसाइड द बलून. ओके, आतल्या इलेक्ट्रिक फील्ड मध्ये काय चेंज होईल का, असं त्यांनी विचारलं. इफ द चार्ज इज डिस्ट्रीब्युटेड युनिफॉर्मली, युनिफॉर्म चार्ज डिस्ट्रीब्युशन असेल तर मला बाळांनो सांगा इनसाइडची इलेक्ट्रिक फील्ड किती असते. नाउ द आन्सर शॅल कम फ्रॉम यू. If uniform spherical charge distribution is there, what is the electric field inside? Inside ची electric field किती असेल? This is as good as a metallic cylinder, metallic sphere. कारण metallic sphere ला पण surface वरती uniform charge density असते. आता metal नाही दिला, non metal दिलाय. It is a rubber balloon that we know, but charge distribution is uniform. Center ला किंवा inside anywhere electric field किती येणार? E inside for this uniform spherical. Yes, Sarosh, you are giving the correct answer. Very good. बोला बाळांनो, बाकीच्यांनी पण बोला. इनसाइड ची इलेक्ट्रिक फील्ड सिमेट्रिकल चार्ज डिस्ट्रीब्युशन असेल तर इनसाइड ची इलेक्ट्रिक फील्ड किती येते. आन्सर इज व्हॉट. रिप्लाइड, इट वोंट टेक मच टाइम. इट इज व्हॉट. इनसाइड ची इलेक्ट्रिक फील्ड किती असेल. सिमेट्रिकल चार्ज डिस्ट्रीब्युशन असेल तर इनसाइड एनीवेअर इलेक्ट्रिक फील्ड किती. ओनली वन रिप्लाय एव्हरीवन. तरी मला लक्षात येईल ना, म्हणजे तुम्हाला माहित आहे माहित नाहीये. इनसाइडची इलेक्ट्रिक फील्ड किती असेल. आउटसाइड एनीवेअर के क्यू अपॉन आर स्क्वेअर 1/4 पाय एप्सिलॉन 0 क्यू अपॉन आर स्क्वेअर. आउटसाइड एनीवेअर. इनसाइड किती. इनसाइडचा आन्सर किती. कशिश, व्हॉट इज द आन्सर. Inside anywhere, what is the electric field? Vaidehi, what is the answer? Inside anywhere electric field is 0. So write down 0. So inside anywhere electric field is 0. Yes, Asta, you have given the correct answer. So inside anywhere the field is going to be 0. Sir, if the inside anywhere field is going to be 0, now if we blow blow this balloon, what will happen? Its surface area will increase, but still the charge distribution will be uniform. Still the charge distribution will be uniform, and if the uniform charge distribution is there, anywhere inside the field is going to remain 0. So you will here simply, with the help of thoughts, you will choose option number 2. No calculation required. A simple thought of uniform charge distribution, spherically uniform charge distribution, if it is there, anywhere inside electric field is 0. That simple thought is to be used. That will complete question number 5. Next, question number 6. Let us read. A hollow metal sphere. Now this is a metal sphere, okay, of radius equal to 10 centimeter. So first of all, we are given metal sphere. Yes, sir. What is its radius? Sir, r is equal to 10 centimeter. Yes. Is charged such that the potential on its surface is 80 volt. त्याच्यावरचा charge असा आहे such that potential on the surface is equal to what? 80 volt. Okay, sir. The potential at the center of the sphere is, very simple question. Very simple question. You people tell me, on the surface, if potential is 80 volt, and this is a metallic sphere, so charge will be distributed uniformly. Sir, charge will be distributed uniformly means anywhere inside potential, anywhere inside electric field will be 0. आत कुठेही field किती असेल? 0 असेल. इलेक्ट्रिक फील्ड 0 असेल. अरे इलेक्ट्रिक फील्ड 0, इलेक्ट्रिक फील्ड काय असते? E is equal to minus dV by dr. Sir, electric field 0 means constant's derivative 0 येतं. It means minus d by dr of some constant value. What is that constant value? That constant value should be everywhere, anywhere inside electric field तर 0 आहे. Anywhere inside electric field तर 0 आहे. So anywhere inside electric field जर 0 असेल तर anywhere inside potential काय असलं पाहिजे?